Welcome to our video tutorial on solving for aspects of a circle based on intersecting segments inside or outside of the circle. In this particular problem, we want to find the shaded area. There's also two types of special points that pop up. Here, we've got a point formed when segments intersect inside of a circle, and over here we've got a point that is formed when segments intersect outside of a circle. Where do we have to begin? Well, if we begin with this point, we're missing a portion here and we're missing a portion here. So we'd be kind of stymied. We'd be stuck. We wouldn't know what to do. Up here, however, at this point, we're only missing one piece of information. So we're going to start at the point that we have colored in blue. And we're going to remember that when chords intersect inside of a circle, the formula is that the part times the part is equal to the part times the part. Now on the one chord, its parts are 10 and 2. So we'll fill that in, 10 times 2. On the other chord, we don't know this portion. Let's call it x. And the two parts will be 4 and x. As we solve for x, 20 is equal to 4x, or x is equal to 5. Now in this particular problem, we can proceed to the point outside of the circle. The equation is that the outside portion times the whole thing is equal to the outside portion times the whole thing. Well, on the outside portion of the upper secant would be a 15. The whole portion, 15 plus 5 is 20, plus 4 is 24. Again, that's the 15 plus the 5, which is 20, plus 4, which is 24. On the bottom portion, the outside part is 10. We don't know the whole thing. Let's call the whole thing something, but we can't call it x. We've already used an x, so it might be wise to go with y. And as we solve, 15 times 24 is going to be equal to 360. So we get 360 is equal to 10 times y. And we'll divide both sides by 10 and get that y is equal to 36. Now as we go to try to solve for the area of the circle, the area shaded in the circle, we need the radius. To get the radius, we would take that whole portion, which is 36. We would subtract away the part we already know, which is 10. And then we have to split it in half because that's the diameter and we just want a radius. So the radius is going to be 26 divided by 2, which is 13. And therefore, our shaded area is going to be half of a circle. So it's 1/2 pi times the radius squared. Our radius is 13. So when we take 1/2 times pi times 13 squared, we get 265.47. And please give us the answer correctly rounded to 2 decimal places. There were no units in this problem, so you do not have to give us a unit in return. Just 265.47 would be fine. So when you're dealing with problems involving intersecting segments in or outside of a circle, remember our two formulas. Use them to solve for missing portions of the picture. And then if another aspect of the problem is what we need to solve for, figure out how to go about doing it. Overall, hopefully once we get the hang of this and have the formulas down, these problems really aren't that bad.